Okay, in this little video I'm going to prove the log laws, and they will all be related to the exponent laws. The first exponent relationship we know will be that a to the power of 1 is equal to itself. Writing that as a log law would simply be rearranging it to write it as a log expression, which means that log base a of a, so log base something of itself, must equal 1. So there's your first log law. Now the second law again, this is linking to an exponent expression, and this time we know that a to the power of 0 is equal to 1. In fact, anything to the power of 0 is equal to 1. And again, rewriting this as a log expression, we get that log base a of 1 is equal to 0. Okay, so this means that log, no matter what the base, if you take a log of the number 1, you will always get the answer 0. Now the third exponential relationship which we want to relate it to is the idea of multiplying exponents. So we have a to the m times a to the n is equal to a to the m plus n. Okay, in this particular case, we have to define some expressions. So, to do this, we will say let x be an expression which is equal to log a of m. And let y be the expression log a of n. Now, using our knowledge of exponents, we can rewrite these as a to the power of x is equal to m, and a to the power of y is equal to n. Okay, so now using my log law, my exponent law, we can say that a to the power of x times a to the power of y is equal to a to the x plus y, which is equal to, of course, m times n. So we now have a new expression. Looking at the second half of that expression, we can rewrite this in using our logs. So log base a of m times n, or we're going to put it in brackets to make sure it's clear, must equal x plus y. Now, using these x and y, we have expressions for x and y, so we can therefore write that log base a of mn, again, originally writing without the multiplication, will equal log base a of m times log base a of n. So there's our log law. To use this log law, we could write any expression. So therefore, we could write that the log base, anything we like, let's use 10, of, say, 42 would equal log base 10 of 7 times 6, and put it in brackets, and that therefore is equal to the log base 10 of 7 plus the log base 10 of 6. Alternatively, we could say that the log base 5 of x plus the log base 5 of x plus 1 would equal, using the log laws, that would equal the log base 5 of x times x plus 1. Obviously, we must note that the bases of both these logs must be the same for this log law to work. Okay. So, a to the n divided by a to the n is equal to a to the m minus n. There's our exponent law, and we can now use this to develop our log law. If x is equal to log base a of m, then we can say that a to the power of x is equal to m. Similarly, if y is equal to log base a of n, then a to the y is equal to n. Using these expressions, we now can use our law, our exponent law, and we have a to the x divided by a to the y is equal to a to the x minus y, which of course we know is m divided by n. Converting this expression, the second half here, back into logs, we therefore get log base a of m divided by n is equal to x minus y, which is log base a of m minus log base a of n. So we can use this one, and we end up with log base 7 of something simple, x over y would equal log base 7 of x minus log base 7 of y. So we can split up a single term with a division into the subtraction of two logs. Similarly, if I have log base 4 of 3x and I subtract log base 4 of 2y, I can combine these inside the single log as log base 4 of, open bracket, 3x divided by 2y. Now the last exponent law is that a to the power of m to the power of p is equal to a to the mp. So we multiply the powers. In log terms, we know that x is equal to log base a of m. We also know that 2x is log base a of m plus log base a of m, which therefore must equal, using our previous law, log base a of m times m, or log base a of m squared. And the same property applies. So if I have p x, that would be the same as log base a of m plus several times plus log base a of m p times, which therefore would be p log base a of m, but also log base a of m to the power of p. Now this one can be used if I have and I want to manipulate a term such as log base 7 of x cubed, I can rewrite that as 3 log base 7 of x. And vice versa.